of linear equations. Okay? So what I'm going to do here, gentlemen, okay, what I'm going to do here today is do the hardest part with you, which is coming up with the equations. So taking the words and making them into equations, okay? Next day when you come, I will show you how to solve them. But right now, you don't know how to solve them. I just want you to know how to create the equations, okay? So here's a simple example that I want to take a look at. Here's example number 1. For school play museum. By the way, any of you actually go to museum? Oh, that's good. Good play? Yeah, it's all right. You were in it? Yeah, I thought it was pretty good. Anyways, did you know that adult tickets cost $15? Yeah, scam. I know. And student tickets cost $10. Bigger scam. No, no, no. You didn't pay? I made up the numbers. Don't worry. Okay. So, anyways, $15 for adults, poor man like me. Student tickets cost $10 each. Now, on the Friday evening performance, there were 425 tickets that were sold. Okay. Now, here's what I like us to do. It says to determine how many of each type of ticket was sold, we can write two equations to model this situation. Okay? Now, the first thing you always need to do when you look at these word problems is identify the unknown quantities. What are the two things that are unknown here? How many adults, not seniors, adults, okay? How many adults and how many youth? Okay, so let's give it some variables. What letters would we like to use? X and man, you guys are so boring. X and Y. Fine, we'll use X and Y. X stands for the, let's say, the number of seniors. No, 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 the number of adults. Okay, the number of adults. I meant to say adults. And then let's use Y as the number of youth. Fine, of students. Okay. By the way, if you want to be more creative, use more creative letters like maybe A for adults and S for students. You know. No. You can use a smiley face and I don't know, star. No, 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 don't put that. Just use letters. Okay, just use letters. By the way, there are two letters you must never use. Do you know what two letters you never use? No. Don't use O because you're like, is that O or zero? Or yeah, L or I. Like what's that? One or I. So don't use those. Okay? Everything else, fair game. All right. Once you've found the variables, now I want you to translate this. It says, translate the total number of tickets sold into an algebraic equation. So if the total number of tickets sold were 425, well, what kind of algebraic equation can I create using those two letters that we just used over here? Say that louder, Jose. Exactly. Notice X is the number of adults, Y is the number of students, and if I put them together, the total, it should be 425. Awesome. Okay, now, here's the harder one. If the show collected, meaning it earned $5,125, I want you to now translate the total value of the tickets into an algebraic equation. Okay, now let's think about this. Each adult ticket costs how much money? 15. So if I bought 2 adult tickets, how much would it cost me? 30. If I bought 3 adult tickets, how much would it cost me? 45. If I bought 4 adult tickets, how much would it cost me? What am I doing? I'm taking 15 multiplied by that number, the number of tickets I bought. How many tickets were bought for the adult tickets? You don't know, but what do we call it? X. So how do we figure out the value of how much money that costs? 15 times, yeah? Times what? X. Good. So here we go. 15 times X gives you the value of the adult tickets. Say it again. Plus what? Patrick says plus 10Y because, yeah, every student ticket raked in 10 bucks. And this should equal how much money? Excellent. Hey, look at that, ladies and gentlemen. You just actually translated words into algebra. Bravo. And if you can do this, that's pretty much what we're going to do today. So what I want to show you now is this, the two linear equations, and let's copy them down once again. X plus y equals to 425, and 15x plus 10y equals to 5,125, okay? These two linear equations model the situation, meaning they describe the words that we talked about. In math, these two equations form what we call a system of equations in two variables. Okay, so a system, it's a combination of things. A system of linear equations is often referred to just as a quick system. Okay. So ladies and gentlemen, this whole chapter is about coming up with these equations and then being able to solve for x and solve for y. Now, suppose that you were told by the usher at the event that 175 adults showed up and 250 students also showed up to this evening performance. How could you tell if he was telling the truth? So how do I know if he's lying to me or not? Put it into the what? Equations. Which one? The second one? Why not the first one? It doesn't multiply the cost. But I'm talking about people. You're right, I have to put it in the equations, but which one do I put it into? It's this one, yeah. And it has to be both. It has to satisfy both. So yeah, how could you verify you was telling the truth? You're saying this, yeah. You're gonna say plug the numbers, okay? The numbers into the equation, but I want you to please write down and put an arrow here because I want you to say both, okay, equations. You can't just put it into one because there's two equations that describe the scenario. The answer has to make both, okay, satisfy both the equations. So don't just be lazy and plug it into one. Plug it into both. And so what I want you to understand here is the following, okay? A solution to, or a solution of a two-variable linear system is really a pair, remember there are two answers, right? A pair of values that satisfy, and here's the key word, both equations. Okay? So here's what I'd like us to do next then. Let's see if he was telling the truth. Let's plug both these numbers into both those equations and let's see if they make sense. So I'm going to write down both equations first of all. X plus y equals 425, and I'm going to try and color code this. And then I have the other equation, 15x plus 10y equals to 5,125. Okay, and if you can't color code it, that's fine. At least, separate them. And then I'd like you to then please check to see if he was correct. So what would I plug in for x, and what do I plug in for y? Good. So x is 175. Thank you very much. I'll plug that in. And then y is 250. And my question here is, does this equal to 425? So what's 175 plus 250? 425. Does 425 equals 425? Let me know. Yes. So this one's okay. But don't forget, I said don't just plug it into one, plug it into both. So let's go ahead and try that one over here. 15 times, what's x again? I forgot. Okay, good. And then y is the adult number of tickets, that's 250. And once again, I'm asking you to see if this left side equals to the right side, 5,125. Oops, what happened there? Whoa. Okay. So can you please try to evaluate these terms? What's 15 times 175? I've got no calculator. I'm poor. One what? 2625. And then this one I know how to do. That's 2500. Add them together. Oh yeah, I think it works. Okay. So this one's yes as well. So was the usher correct? Yes. The usher was correct. Okay. All right. Now, ladies and gentlemen, like I said, Today I'm not going to show you how the usher got his numbers, okay? But next day when you come, I'll show you how to solve these questions. But until then, today's little task is just having you be able to translate words into equations. So we're going to do some practice with that now on page 2. And what I'm going to ask you to do is you need to first of all identify two variables. If you want to use x and y, so be it. If you want to be more creative, use something else, that's okay. And then I want you to create an equation using those variables. Okay? Shall I do the first one with you together? Okay. It says two numbers have a sum of 75. Okay, now what are my variables? Okay, x and y. But what do they represent? The two numbers. Okay, maybe x will be like the smaller number. Okay, smaller number. Can I use the number sign for number? I'm lazy. Is that okay? And then y is the larger number. Okay, large number. Because they are two different numbers. And if I said two numbers have a sum of 75, what does that mean? X plus y equals to 75. Done. That's it. Okay. So part B, let's read that. And once again, what are my two variables and what do they represent? So I got two numbers now, such that 7 more than the first number is double the second number. Ayah. What do we do here? What are my variables? X and y again? Man, you guys are boring. Okay, fine. X and y. What's x represent? Or in this case, I'll just use the first number because we're talking about the first number and second number. So I'll say first number. Okay, it could be the small number. I don't know. But because I didn't talk about bigger or smaller, I'll just use first and second number. Okay, so there's your variables. Yay. So it says 7 more than the first number is double the second. What's 7 more? Plus 7. Okay, so I'm taking the first number and I'm going to do what to it? Plus 7. Good. By the way, the word is in math represents what sign? Equal, yeah. Is just another simple way of saying equal sign. So equal to, that's right, double means twice, 2 times y, 2y. Done. Okay, you try the next one, please, on your own. Okay, see if you can find the two variables, describe what they are, and then come up with the equation. By the way, what are my two variables for part C here? Pens and pencils? Oh, x again. Fine. X is what? Pencils. Now, be careful, okay? You can say pencils, but what am I talking about? The cost of the pencil, the number of pencils? Like, what is this? Yeah, like the number of pencils. So I'll say, just to be more specific, the number of pencils, just so that you don't get confused with the cost. So that means how many pencils you have, okay? And then I guess for you guys, it's going to be boring. Why? Yeah. The number of what? Pens? Okay. Don't use P and P, by the way, because then you can't tell the difference between which one, right? Yes, you can. You can say like capital P and like curly P. Is that what you're going to do? Yeah. PP. Don't do that. Okay. 4 pencils. 3 pens. Cost $250 total. Help me out, somebody. 4x. Sure. Oh, wait a minute. What's the problem here? X is not the number of pencils. It's the what? Yeah, sorry, it's the price. Oops. Because I'm not really talking about the quantity, right? I already gave you the quantity, so you're not looking for that. X is actually the price of the pencil then, right? Oops. So 4x plus what? 3y. That equals to 250. Good. And then D, my two variables. Can we do something more interesting instead of X and Y, please? A and B? Can we do something more descriptive than that? Ah, N and D. Very good. N stands for what then? I guess they're talking about the number of nickels, right? How many nickels you have? The number of nickels. Now we're getting more exciting. N and D, yes. D stands for the number of dimes. Go answer your text. Okay. What do we have now? A number of nickels and a number of dimes has a value of $2. How much is a nickel worth? 5 cents. Right. So 0.05 N, right? And then how much is a dime worth? 10. So 0.10 D. And if I add that together, the value is how much money? $2. So that's 2. Or 2.00. Okay. Now, in example number 2, dear friends, you only created one equation. Okay? But remember I said this chapter is about systems of equations. So systems meaning you have more than one equation together. So that's what the next example, number 3 and number 4, will be like. And then after this, we'll be done. So this is a quick lesson today. Okay? So what I'd like you to do now with number 3 is I want you to create a linear system to model the following situations. Okay? And I'll help you with A, and I want to let you try to do B on your own. Okay? What's the first thing we always do? Sleep. No, after you sleep. Eat. Okay, after you eat. Do math. Okay, after you do math. Variables. Yes. What are my two variables in this case? It says the sum of two numbers. Okay, let's go back to your boring X and Y. Sure. What's the X? What's the Y? Two numbers. So which one do you want to call it? I don't know. The first number, second number? Okay, first number, second number. Who cares? Okay. Once you've got your variables, let's see if you can come up with two equations now. If the first part says the sum of two numbers is 176. What does sum mean in math? Add. So what am I adding here? X and Y. Good. So X and Y equals to what number? Good. The sum of two numbers is 176. Okay. What's the next part? And their difference is 48. What's difference mean? Subtraction. So take the two equations, or take the two variables, subtract them, and what's that equal to? 48. Done. That's it. Here is your two equations. This is your system. Done. Okay, you try part B, please. Okay? You decide what the letters are. You try what part B is. Okay? On your own. So try to think about this as a picture with length and width. So I guess that means your two variables are L is length, W is width. Okay. So from there, can you move forward and try to find two equations? I'll let you think about it.
Well, that's what you said.
Okay, the perimeter of the rectangle. How do I describe the perimeter? 2L plus 2W is 64. Awesome. Good. There's your first equation right there. Okay, now let's do the next part. Twice the width, 2W, is equal 4 centimeters more, 4 plus 3 times the length, 3L. Done. Okay. And by the way, if your order is different, if you wrote down 3L plus 4, that's okay. Same thing. Okay. Let's do part C. Yes, sir, Lawrence.
Can you do 2W minus 4 equals 3L?
Oh, yes. So Lawrence said, Mr. Lee, can I do this? 2W minus 4 equals 3L? For sure, because that just means you subtracted 4 on both sides. Same thing. That's good. Yep. Okay, let's do the last one. Part C. Mr. Lee rented a car for 3 days and drove 160 kilometers and was charged $124 during Christmas break. He also rented the same car for 5 days and drove 400 kilometers during spring break and was charged $219. What's the deal here? What are my two variables going to be? How much? The what in kilometers? The what? The days. Oh, okay, so D means the charge per day, right? How much money it costs me per day. So if you rent a car, they usually have a rental fee of this is how much per day. But of course, you're using the car, so there's also a charge for how far you drive. So maybe I'll call, I don't know, what's my other variable? K. Okay, so the charge per kilometer driven. Okay. So once you've identified your variables, I hope life is pretty straightforward. Huh? Oh, DK Donkey Kong, right? DKNY. I don't know. Okay, so help me out. Let's go back and read the question again. He rented a car for 3 days, drove 160, charged 124. Help. What's the equation? 3D. Yeah. 160K equals 124. Sweet. He also rented the same car for 5 days, drove 400 kilometers during spring break, and was charged 219. 5D, yeah. 400K equals 219. Congratulations. Done. Okay. All right, turn the page. I got 2 more examples with you, and I'm done for today. Okay. That's fast, I know. But you still have to work on the homework, okay? Just because you get it now doesn't mean you're going to get it when you go home and do it. So please practice. Okay, the last 2 are a little more tricky. But the last 2, I'm going to show you how to do this by organizing all this information in a little chart or a table, okay? How many of you taking science right now? Yes. What's the relationship between distance, speed, and time? It's not that hard, but what do you have? Distance equals to velocity, sure, or speed times time. By the way, have you guys seen this triangle thing before? Oh yeah, you hate that triangle thing. Okay. D, S, T. Distance, speed, time. Say again? I could, but I don't. I'm a better math teacher. I don't know. Maybe I'm a bad science teacher. I don't know. Okay. I actually never taught science before. I taught business before. Anyways, I'm progressing. Anyways, here you go. Let's take a look at this question here. The Andersons, my good friends, my next door neighbors, okay? They traveled 880 kilometers from St. John's to Halifax. That's, by the way, back east in Atlantic Canada. Beautiful place, by the way. Do you know that in Atlantic Canada they have a special sandwich at McDonald's? It's called the McLobster. Seriously, it's called the McLobster. It's like a hot dog bun, but inside is lobster meat. Big chunks of lobster meat with some mayonnaise. It's good. Anyways, if you ever go to Atlantic Canada, okay, have a McLobster. It's better. Okay, part of their trip was by car, traveling at an average speed of 80 kilometers per hour, and the rest of it was by ferry. Okay, and it says the total traveling time for the entire trip was 27 hours. Okay, all this information, I'm getting confused. I don't know what to do. Think about this. Can you tell me this? What's the speed of the car? What was the average speed of the car? 80. Okay, let's write this down. 80. Okay. What's the average speed of the ferry? 16. Okay. Now, do we actually know the time it took that guy drove in the car? Do you know the time he was on the ferry? No, we don't. But do we know their total time? We do. Okay, so stuff we don't know. What do we call it? X. Okay. How about T? Sure. X, Y, T, A, B, C. T? Okay, let's make it nice. T. T is the time in the car. Cool. Okay, so let me call T time spent in the car. Okay, now for those of you who thought, okay, T is the time for car. What's the time for ferry then? T again? F? Oh, F for ferry. Oh, okay. All right. F. F equals to time for ferry. By the way, if this was the case, why don't you just call the time for the car C? Wouldn't that have been better? Okay, so what I'm telling you here is it doesn't matter what the variables are, okay? Just choose something that you like and label it. Okay, T and F. All right. By the way, didn't you just tell me that the total time was how much? So can you come up with the equation right now with T and F? T plus F equals to 27. Right on. Good. Now, what other piece of information have we not used yet in this equation? Distance. The Andersons traveled 880 kilometers. Well, I guess what I'm saying to you is you need to figure out something for distance. Now, we don't know how far he went in the car. We don't know how far he went in the ferry, but we know the total distance is 880. Okay, now this is where the physics part comes in. How do we calculate distance if we know speed and we know time? Multiply. Distance equals speed times time. Distance of the car equals to speed of the car times the time of the car. What's 80 times t? That's just 80 t. So, what's the distance for the ferry? 16F. Nice. And you just told me the Andersons traveled 880 kilometers in total. So what's my other equation? 80t, the time in the car, or not time in the car, distance of the car, plus 16f, the distance traveled by ferry, equals 880. Congratulations. Done. There's your system of equations. Can you go home? No. Okay, one last one. Okay? This is a classic example. Classic, meaning see it on a provincial exam. That means see it on Mr. Lee's tests. That means see it everywhere. Meaning do this and do it right and understand it. Got it? Yes, all this stuff is pre-calculus stuff. So for those of you taking pre-calc 11 next year, you'll see this stuff again. Okay? All this stuff in the later half of the grade 10 curriculum, chapters 5, 6, 7, are definitely pre-calc 11. Okay? Okay. This is one of those speed questions too. But have you guys actually traveled on the river before? Do you know what happens when you're in a boat? What happens in a boat? Boat goes upstream. Boat goes what? Downstream. Now, do you know that sometimes you go faster one way and slower the other way? Do you know why? Current. What's current? Flow of the water. So, if the flow of the water is against you, what happens? Slower. If the flow of the water is with you, faster. Okay, listen up. Shh. Okay, so a boat has constant power, meaning the speed is like the same. It travels up river in 3 hours, and it returns. Sorry, there should be S on here, and returns in 2 hours. Now, when you go upriver and when you're returning, you go downriver, right? So sometimes the words will say upriver, and this one will say downriver. Okay? Oops. Downriver. Return, aka also known as downriver. Okay? Or upstream, downstream, whatever they call it. So here's the question. Find the speed of the water current, meaning the speed of the current, and the speed of the boat relative to the water current. So what are my two variables, first of all, here? Speed of what? Boat. Okay. What letter do you want to call that? B. Oh, very nice. B equals to the speed of the boat. And what else are we looking for here? What's my other variable? So what else? Current, right? The river flow. C. Oh, right. Okay. Speed of the river current. Cool. Okay. I gave you a little chart here, but what are we going to put in this chart? Huh. Well, if you want to copy the same stuff as before, then I guess it's speed. then there's time, and there's distance. Okay. Now, what are my two rows going to be here then? What are my two situations? Go what? Current. Well, what am I doing? I'm going upstream, and then I'm going. Right. So upriver and downriver. My two separate scenarios. Okay. Okay. So it's time to fill out the chart. What do you know? Nothing. Okay, good. That's why you're here, to learn. Read the question. What does the question say? Patrick, upriver 3 hours. So at least Paula says I can put a 3 in that spot right there, right? 3 hours. Okay. Anybody else get some other information? 2 hours downriver. Good. 2 there. Speed is 60? No. The distance is 60 upriver. Isn't it constant? That's right. So listen up, ladies and gentlemen. The distance going upriver is 60, but so is the distance going downriver, right? It's also 60, because if you go up 60, you gotta go down 60. There's no other path. Okay? Now, you saved the best for last. How do we describe the speed going upriver? Okay, now before I do distance by time, all that kind of stuff, because you like physics, I like physics. Ew, who likes physics? Okay, let me ask you to use the variables that you're given here to help you out. Okay? B stands for the speed of the boat. What did I tell you when you go upriver? The boat and the current are in opposite directions, so they make you slower. So what's my variable here? Say it again. B. I heard it. If you said B minus C, you are correct. It's the speed of the boat, okay, B. But then because the current pushes against you, against is minus, so you actually lose some speed. Okay. How about downriver? Yeah, that's when the boat and the current are going with you together. So the speed is faster, B plus C. Okay? Now, it's up to you what you want to do next. Oksana was saying, using physics, what's speed equal to again? Distance divided by time. So if I were to just do a little quick column here and say, well, speed is equal to distance divided by time, we have those numbers, don't we? What's the distance and what's the time going upriver? What's the distance going upriver? 60. What's the time going upriver? 3. What's 60 divided by 3? 60 divided by 3 is? 20. Right. So this is just equal to 60 divided by 3. What about the speed going downriver then? That's 30, because that's just 60 divided by 2. Right. Now here's what you have. You've got two things that equal speed. B minus C is the speed going upriver. So is 20. So what's your equation? How about B minus C equals to 20? Do the same thing. Same thing. And what else do you have? B plus C equals to 30. All right, ladies and gentlemen, that's it for today. Get cracking on these, please. Study for your review exam. I'll put up the answers online tonight. And then next day when you come, we'll do section 7.2, learning how to solve the systems of equations.